Welcome to Brain Vision.
Question number 91 is a wavelength calculation from energy. So we'll use the energy of a photon equation where the energy is equal to Planck's constant multiplied by the speed of light for the photon divided by the wavelength of the photon. So we could rearrange this equation and solve for the wavelength if we know the energy per photon. We don't know the energy per photon, but what we do know is the total energy. We can calculate the total energy by taking the milliwatts, 20 milliwatts, so 20, milli means 10 to the negative 3, so 20 times 10 to the negative 3, a watt is a joule per second, and then multiply that by the total number of seconds that is in an hour, 3,600 seconds. So the total number of joules then that are created by the laser in an hour is 72 joules. Knowing the total energy, we can calculate the energy per photon, which is what we need to use this equation, by taking the total energy divided by the total number of photons, given to us as 2.29 times 10 to the 20. So the energy per photon is 3.14 times 10 to the negative 19 joules per photon. The wavelength then can be calculated by taking this equation, rearranging it to solve for lambda. Lambda equals hc over E. H is Planck's constant at 6.626 times 10 to the negative 34. C is the speed of light, which is also a constant, 2.9979 times 10 to the 8, divided by the energy per photon that we just calculated, 3.14 times 10 to the negative 19, and we get 6.32 times 10 to the negative 7 meters as our wavelength, or 632 nanometers.